Welcome, students. We are about to begin our journey into calculus with our three-dimensional vectors. First up, the definition of a derivative and tangent vector. If you will notice, the derivative for your vector r is just each of those functions for each of the components, just the derivative itself. Now how that was arrived at is as follows. Just the definition of the derivative was used for each of the components, and then they were just reorganized into each of the functions for each component, and then you were able to see that you just arrive at a very straightforward derivative. First step, we're to compute the derivative for each of these two vectors. R prime of t would then be to just take the derivative of each of the functions for each component. 3t squared in the I, 6t for the j, and then bringing down my 3, that would be t squared over 2 for the k component. And all of this is differentiable on all t due to the fact of the functions themselves. R prime of t, doing the same thing again, negative e to the negative t. This is only valid where t is greater than 0, so we'll have to put that restriction on there. The derivative of 10 t to the 1/2, bring that 1/2 down, that would be a 5 over the square root t, and then so it'd have to be t greater than 0, couldn't include that 0 here. And for this one, what I'm going to end up with is I'm going to say take the derivative of the outside, that'd be a negative sign, and then take the derivative of the inside, so that would be negative 6 sine, leaving that inside alone for that k direction. And I can write that in terms of I, j, and k, if you will. I can write it with parameters, or I can write it in this vector notation. Seeing as they gave it to me with an I, j, and k hat, then I should leave it as such. So e to the minus t I hat plus 5 over square root t j hat minus 6 sine 3t k hat. Alright, next we're going to need to find the unit tangent vectors. So first up, you'll first need r prime, so 2t, that would be a 4, and then this one would just be a 4 over t. Right, now I need the magnitude by my definition here, just like unit vectors from before. I'll need the magnitude of that derivative vector. Probably ought to be putting this on here. Of t, and it's the same as before. I'm just going to have 2t quantity squared plus 4 squared plus 4 over t quantity squared, and then I'll just compute that. Okay. Now this unit vector of t is going to be just that, 2t 4 over t divided by that magnitude, 2t plus 4 over t for each one of those. Nice. Okay. Just playing it again. I might note that this has got to be for t greater than 0, and that looks like they've already noted it, so I didn't really have to. Okay. Next I'm going to get 0, -3 sine t for my derivative, and then just 3 cosine t. Gotta find the magnitude. Get my notation a little better here. And that's just going to be 0 squared plus -3 sine, sine t quantity squared plus 3 cosine t quantity squared. This is going to be an identity. I'll go ahead and get that. That one ended up really nice. So now my unit vector, unit tangent vector actually, is just the 0 divided by 3, which is just 0, negative sine t when I divide by 3, and cosine t when I divide by 3. Very pretty. Alright, here are the derivative rules for vectors. So let's play. In this one I am to take and find the derivative of replacing my t with t squared. So that's going to mean that I'll need to use the straight up chain rule, which is exactly the same as before. It's take the derivative of the outside, leave the inside alone, times the derivative of the inside, just like before. So with each of these t's being replaced with t squared, I'll take the derivative of the outside. Derivative of sine would be cosine t squared, times the derivative of the inside, which would be 2t, and that would be I hat, plus, I'm on to j, derivative of the outside, that would be negative sign. So I'll just write the negative sine t squared, and then I'm going to multiply by 2 because of that 2 there, and then the 2t because of the derivative of the inside. So I'll need to write that a little prettier, and that is j hat plus derivative of cosine is negative sine t squared times 2t, and that is k hat. I could make that a little prettier just by saying, well, there's a 2t in everybody, and then just pull that out and note that I have cosine t squared I hat minus 2 sine t squared j hat minus sine t squared k hat. And that is just the derivative times that, really what that derivative of that inside was. Not too bad. This one's going to be a little messy. It's going to involve the product rule. So I can take the derivative of the first, we'll just say that's 2t, leave the next part alone, sine t I hat plus 2 cosine t j hat plus cosine t k hat plus t squared times the derivative of the second, and that's just going to be cosine t I hat. That would be minus 2 sine t j hat. Derivative of cosine is just minus sine t k hat. Collecting my components, I would have 2t sine of t plus t squared cosine t I hat plus, that would be 4t cosine t, multiply that, minus 2t squared sine of t j hat plus 2t cosine t minus t squared sine t k hat. Lovely. The next one, I'm going to have to scoot this up just a little bit. We'll need some more room. We're going to have to do the derivative of the dot product, and they tell me that the dot product rule says that I will take the derivative of the first, leave the second one alone, not times but dot product wise. So let's find the derivative of the u. That would be I hat plus 2t j hat minus 3t squared k hat. I'm going to write the others down. I almost didn't get all that on there. Now I'm going to do the dot product for each of these, which is just for, the first one, it's going to be the 1 times the sine t plus, and it's 2t times 2 cosine t, so that would be 4t cosine t minus 3t squared times the cosine, so minus 3t squared cosine t. I'll write the rest down because I've got to continue on with the others. Wow, how messy that was. That was really messy. Okay, I'm going to do example 4, but I'm going to move it. That last one sure was messy, wasn't it? Okay, r prime of t is going to be equal to 2t. That's going to be 8 over t. The derivative of that would be minus 6e to the minus 2t. I just keep on going. Oops, double prime. 2, and that's like t to the minus 1, so that's minus 8 over t squared. And doing this again, be 12e to the minus 2t. Alright, play in again. 2, 3. That's going to be a 0. It's like to a minus 2, so that'd be positive 16 now. And then minus 1, that'd be 3. And then minus 24, e to the minus 2t. Oops, 2t. Higher order derivatives. Not too bad at all. Alright, we're going to work this indefinite integral here. You just take each piece and you work each piece. So I'm going to look at this little piece here, and I see that u is, I'm going to do this out to the side, let u equal t squared plus 2. That means du is 2t dt. 1/2 du equals t du. I saw a tu. That's a dt, silly. Okay, so I saw this t dt out here. Alright, so what I've got is, I'm just going to write this as integral of, and I'll write all that down. Alright, so I have all of that, each of the integrals of each of the components written down. So this one, oops, that's supposed to be square root there. So this one, that integral is then going to be just a plain old square root u with a 2 out front, which cancels with that, so that's going to be there I hat plus, for this one it's just going to be e to the minus 3t over negative 3 j hat. Oh, and they need their little plus c's, so let me write plus c1 here. Let me write plus c2, because each of these constants is in a particular direction. So, and for that one to be negative 1/4 cosine 4t plus t plus some c3 in the k hat direction. Alright, if I let, so just to make it easier to write, c, the vector c equal to c1 in the I direction and c2 in the j direction and c3 in the k direction, then I can just write a c vector out behind it just to make my life easier, because it just look a little better. So let's write this as square root of, let me go back to t's here, t squared plus 2 in I hat direction. I don't want that. Maybe I do, I'll just have to see. Oops. Plus, I'll make that a negative. Okay, I've written each of these down, and then I'm just going to say plus some constant vector where I have c1, c2, and c3 are different constants, not necessarily the same one. Alright, we're going to find the antiderivative here, so I would like to know r of t, and that would be the integral of, and I'll just take the integral of each one of these, so I'll just write that down. Okay, writing that down. This e squared is just a constant, don't let that fool ya, and I think after that that's pretty much okay. They say that r of 0 is just plain j, and what that lets me know is that r of 0 equals, and let's put in a 0 for each one of these. That would be 0, put in 0, that would be a minus 1, and that would be a 0. And I know that plus this c vector equals j vector, which is 0, 1, 0. That lets me know that, and I'll need a little more room. I'll write this. Okay, I just wrote down the fact that c vector is 3 separate constants in each of these directions. Looks like c1 is 0. c2 needs to be a 2 in order for negative 1 plus 2 to be equal to 1, and c3 is also a 0. So r of t, which we said was r of t is this guy right here, plus this vector c, is e squared t, then 2 plus that, so 2 minus cosine t, and then just the t squared over 2. And there's how I find the unique vector associated with that integral. For this one, I'm going to take the integral of each component and evaluate from 0 to pi. So I'll have t in the I direction evaluated from pi 0. That one's going to end up being, I'm going to need that 1/2, so that's going to be plus, and that's going to be a 6. I've got to take into account that 1/2 that's going to be multiplied out front, and this will be sine t over 2 in the j direction evaluated from that 0 to pi minus, that's 4t squared over 2, so that's just going to be 2t squared in the j direction, evaluated from 0 to pi, and then I'm going to compute. And that concludes 12.6. Nice stuff. Come see me at the Collaborate if you have any questions, or if you just want to hang out.